Hi folks, so I just want to do a quick example here to talk about the differences between negative and minus because teachers and students often go back and forth between these two things and it can be a little bit confusing. So let's jump right into an example. Let's suppose we have x minus 3 times x plus 2. We have a binomial times a binomial. And here we'll do rainbow or foil or fly fishing or however you want to look at it. First times first, x times x, that's x squared. First times last or outer, that's x times positive 2, so that's plus 2. Inner, negative 3 times x. Negative 3 times x is negative 3x, so that's minus 3x. And negative 3 times positive 2, that's negative 6, so minus 6. Okay, and then we'll collect like terms here. We've got an x and an x. The exponents are identical, so we can collect those like terms. Positive 2 minus 3 is negative 1. So we have an x squared minus 1x minus 6. That's the expanded form for the binomial times the binomial. Now, some of you might be thinking, gee, he went back and forth saying negative for minus and minus for negative. And that's kind of confusing because negative and minus are not the same thing. And it's true, they are not the same thing. So let me go through and try and dispel some of the confusion and explain a little bit why we sort of flip back and forth between saying negative and minus. It's actually a shortcut, okay? So if we take the most simple binomial times binomial question, I'm going to write it out as a plus b times c plus d, okay? The way to do this is FOIL, first, outer, inner, last, or rainbow, or fishing, or whatever you do. So it's a times c, whatever that works out to, plus a times d, whatever that works out to, plus b times c, whatever that works out to, plus b times d, whatever that works out to. Okay, and I just said plus all the way through. I can prove that this is that algebraically. I can prove it geometrically, but we're not going to get into proofs right now. I just want to talk about the mechanics, the techniques of doing this. So if I have x, let's clean that up, x minus 3 times x plus 2, like I did just to the left, what I have is equivalent to x plus negative 3 and x plus positive 2. I'll put a little positive there to emphasize that that's a positive 2, okay? And so when I'm doing my foiling, I'm looking at this here, this minus positive 3, as a plus negative 3. Because we have the integer rule that if you have one thing minus another, that is exactly the same as that first a plus negative b. If you want to prove that, you need to go back to integers. Okay, we could do that, but for now we're just going to look at this as given. So now that I've put these both as positives, right? We've got a positive, sorry, not a positive. See, here I'm doing it again. As addition. We've got an addition there and an addition there, just like we have an addition there and an addition there. Now we can multiply our numbers according to integer rules properly. So we have x times x, those are two variables, x times x is x squared. We have a times d, right? Look at this second term here, a times d, this number times this number. Well, in this case, we have a variable x times a positive 2. So we have plus, notice all of these are pluses, positive 2, plus positive 2x, right? Because the positive 2 is times the x. Inner, we have plus, because these are all pluses, b times c. That's a negative 3 times a positive x. Negative 3 times positive x is negative 3x. I have plus a negative 3x. Okay? And then plus, because all of these are pluses, it's all addition, a negative 3 times a positive 2. Now, negative 3 times positive 2 is negative 6. That's an integer rule. Okay, so notice I'm following everything very, very carefully, and I'm making a distinction between plus and positive, and I'm making a distinction between minus and negative. Okay, I'm being very correct. And now on this line here, I'm going to use my integer operation rules to clean this up a bit. We don't normally put plus negative, because as we know from right over here, plus a negative is the same as minus a positive. So I clean this up. I say x squared plus positive 2 is x squared plus, x squared plus positive 2x, that's x squared plus 2x, plus negative 3x is the same thing as minus positive 3x, plus negative 6 is the same thing as minus positive 6. Okay? And then the collecting like terms, just like before, we've got x and x, those are like terms, so we can collect them. X squared positive 2 minus 3 is negative 1x. We actually have plus negative 1x minus 6. And plus a negative is the same as minus a positive, so we have x squared minus 1x minus 6, or x squared minus x minus 6. Okay? Notice we have exactly the same answer here as we have over here, but look at how much shorter that is. Okay? So the reason that we go back and forth between our pluses and our positives and our minuses and our negatives is because we're being a little bit sloppy to go faster. But it will work out if we consider this to be a negative 3, even though it says minus positive 3. We're basically doing this part right here in our head, right here. Okay, we're considering that to be plus negative 3. And that's the real reason there. So if you want to go super carefully all the way through, you can do that. And in fact, I would encourage doing that a few times until you get comfortable with the idea that we can take a shortcut by imagining minus a positive as being plus a negative, because we know it is, and using that to our advantage through the calculations to make them much faster.